right. So, and you guys are gonna like come together, right? Okay, good. All right. So, welcome back. Is this fake Monday?
Yeah.
It kind of feels like fake Monday. 3-day weekend was great. 6 hours of defensive driving yesterday. Woo! What a way to spend the day. Worked on because Daddy had a car accident right at the beginning of the school year. Yay! That stunk. But anyway, you do defensive driving, and you know things get taken care of that way. Woo. And after you've watched the video 3 times over the course of 10 years, wow, you really know the video well.
When you're on the road, please tell me. So.
Yes, I will let you know. Okay, so let's talk about homework situation, new unit, lots of exciting things. Number 1, tests went really well. So, like, my friend Ile got a perfect score on the multiple choice, which is outstanding. And as far as I can tell, might be the only one in the system to have pulled off that feat. Congratulations. Others did really well on the free response. Others struggled a little bit on the multiple choice. We're kind of all over the place. But generally speaking, you guys did really well on the derivative unit. And I will tell you, derivatives are going to play a huge role in this entire course, everything that we do moving forward. Tonight's homework is 2 parts. Number 1 is to start on the test corrections and the reflection process. If you're Ile and you miss like 1 point on the free response, the correction process is going to take like, a minute, because I even gave you feedback on the one place that you went wrong, but you still have to do the reflection document. If you didn't do as well, I am willing to take the test corrections from you tomorrow at 2:30. I'm going to stay for tutorials tomorrow from 1:30 to 2:30, so if there are some questions that you didn't do so well on, you can just say like, hey, I'm going to stay tomorrow from 1:30 to 2:30, get it done, not worry about the test corrections tonight. Everybody good? All right, so on your way in, you should have picked up the Unit 4 packets. Yep, I think everybody picked that up. You've got the student packet, you've got the problem set packet, you know how this works, we've been here before. The problem set packet contains all the homework assignments that you're going to do over the course of the next 3 weeks. So 3 weeks in the world of Calculus BC is a long time to be in one unit. There won't be that many poster making opportunities for Carmen and others, but there will be 1 or 2. Lunch on Thursday was good, huh? Yeah, more posters are coming. Tonight's homework that pertains to the work that we're doing, so we can get that, is the assignment for lesson 51 in the problem set packet. All the questions are multiple choice. The answer is there somewhere. It's your job to go and find them. Okay. Now, Mr. Link, I'm a little worried about telling the friends this next part about this unit. I love this unit. I love this unit. But last year, this was the pit of despair in the calculus world. It was the absolute worst time to be a senior or to be a calculus teacher. And so some changes have been made to this unit that I hope are going to make this better. The title of the unit is Applications of the Derivative. So we are clearly still finding derivatives. Product rule, quotient rule, chain rule, inverse trig, it's all still there, but now we're going to do applications of all of this stuff. And we're going to do a good job with this. And oddly enough, we're actually going to start the unit by going backwards in time. We're going to go back to the world of limits. And I know some of you might be like, no, I survived that. I'm not going back. You can't make me go back. Yes, I can. Okay, there are 1, 2, 3, 4 example problems. I want you working in your groups to see what you can do with these 4 problems. You've got 6 minutes. Do the best that you can. Use your notes. Talk to others. I'm going to pull some papers from time to time to put up here, and we'll go from there. Enjoy the ride. Get clever. Oh, don't turn the page yet.
It has no razor.
Pay attention to that notation. You know I will be. Life is about to get ridiculously good. I mean, even better. This is the kind of stuff that Stephen Googles at 2 o'clock in the morning. Alright, who's got a good idea for me on the first one? What would you do? David, what would you do? You would factor. Why are you even thinking of factor?
Well, before that, I plugged in 2.
You plugged in 2, and I bet you got 4 minus 4 over 4 minus 2 minus 2. 0, 0. How do we feel about 0, 0? We don't like that. What's it called? Fancy word.
Indeterminate form.
Indeterminate form. The indeterminate form. Aaron, if you wouldn't mind turning off the sound on the laptop. Indeterminate form. Why? Why is it an indeterminate form? This is mission critical. Top left, there should be a little mute button. There you go. Thank you. Why do we call this an indeterminate form? What's the problem? Lewis, what's the problem?
Because you can't divide 0 over 0.
You can't divide 0 over 0, but why do we call this an indeterminate form? What's so special about this indeterminate form?
Because when you have 0 in the numerator, it's 0, but because it's being divided.
Okay, so I want to freeze you for a second. So you've got a rule in your head that says, I know that whenever I take 0 and I divide it by a number, I'm supposed to get
0.
0. Palamon, what's another rule that you're thinking about here?
Whenever you divide the same number by itself, it's supposed to equal 1.
Every time you take a number and divide it by itself, it's supposed to be equal to 1. There's a third rule. There's a third rule that's competing here. 0 divided by a number is 0, and number divided by itself is 1. And the last rule that I want you to be thinking about, when you divide by 0, Lewis?
Is it like infinity?
It's like infinity. How about universe explodes? We can't divide by 0 ever. Are we okay? Indeterminate form, because all these conflicting rules telling you different things. So what's the key here? What I heard David say was factor. So let's factor. I'm going to take limit as x approaches 2. That annoying little brother comes all the way through. X times x minus 2 in the bottom. X minus 2 times x plus 1. The x minus 2's cancel. Limit as x approaches 2. 2/3. How many guys got 2/3? Easy peasy. We've been here before. Problem number 2. Take the limit as x approaches 0. Square root of 4 minus 2 over 0. 0 over 0. Uh-oh, it's a problem. What's the way around it? There's a way around this one. Quotient rule? Quotient rule is for derivatives. We are not talking about derivatives.
Conjugate.
We are talking about limits. What's the key?
Conjugate.
Multiply by the conjugate. The square root of x plus 4 minus 2 over x, if I want to multiply by the conjugate would be square root of x plus 4 plus 2 over square root of x plus 4 plus 2. And you might be thinking, gosh, why is that good? Why is that better? Why is that better? Well, if I were to multiply this out, I'm going to get the limit as x approaches 0, multiply out the numerator, but be careful. Square root of x plus 4 minus 2 times square root of x plus 4 plus 2. We know this is really difference of squares. It's like the factored version. So square root of x plus 4 times square root of x plus 4 is x plus 4. Negative 2 times positive 2 is negative 4. So that's just going to get me x in the numerator. In the denominator, x square root of x plus 4 plus 2. Sorry. We're going a little timer crazy today. 1 over the square root of x plus 4 plus 2. Evaluate, you're going to get 1/4. These first two, these are things we were doing like second and third day of calculus. Welcome to day 39. We're doing a whole lot more now. Third one. Anybody get anywhere with the third one?
No.
Stephen didn't get anywhere with the third one?
Oh.
North Central, East End, care to phone in? There's something I want you to see in this third one. Limit as x approaches pi over 3, cosine of x minus cosine pi over 3 over x minus pi over 3. There's something special here that no one's seeing. Maybe Lewis. There's something very special about this form. This is not a random question that I'm asking you. There's something special I was hoping people were going to see. Helmut?
Cos pi over 3 minus cos pi over 3 is going to just be...
If you evaluate at pi over 3, you get cosine pi over 3 minus cosine pi over 3 over pi over 3 minus pi over 3, which is 0 over 0. But there's something special here. And I'm a little surprised that no one's seeing it. This is a hidden derivative question. This is a sneaky derivative question. Why is this a derivative question? Why is this a derivative question? It's a sneaky derivative question. I'm not using the word or the notation. Lewis, what's the thing that you see here? Poem? Cosine x minus cosine pi over 3, x minus pi over 3, so that's what you got.
It's like you're finding the slope between 2 points.
You're finding the slope between 2 points. Specifically though, you've got f of x minus f of a over x minus a, and you're taking the limit as x approaches a. This is our first definition. This was our first encounter with the derivative. This is f prime of a. Ms. Blakely at East End likes to call this like a sneaky derivative question, or it's a hidden derivative question. Is everyone seeing it now as a derivative question? What derivative am I taking? The derivative of what function? Cosine of x at what point? At pi over 3. Function minus function at a divided by x minus a. So now this should be easy peasy. Derivative of cosine, you guys know, is negative sine. Evaluate at pi over 3. We get negative sine of pi over 3, which I think is negative square root of 3 over 2. I would put a little star next to this one because clearly if I get you on it once, I'm coming back for you. All right, and last one. There's something different here that I hope that you see. Limit as x approaches infinity, e to the 2x plus x, x to the 4th plus 3x squared. I'm going to let y'all dangle on this one for a little bit. This is supposed to be a wicked quick one. Stephen, what you got for me?
Infinity.
Infinity. Why are you thinking infinity?
Because the
The numerator is an exponential. The denominator is a polynomial. Which one grows faster? The exponential. Now, please keep in mind, this is only something we do with infinite limits. If this was like limit as x approaches 0, wouldn't do it. So the answer here is infinity, and we came across this when we were dealing with like relative growth rates, or some books call it relative magnitudes. You need to know that the slowest growing function of them all is the log function. After that, we move into like polynomials and we look at their degrees. After that, we hit exponentials. Exponentials grow faster than anything else. Mostly okay? Okay, total review. There was nothing new here. Now comes the new stuff. You might want to weep a little bit because your life is going to get so good. All right, Aaron, can I get you to read the introduction?
In AP calculus, we learned that 0 over 0 and infinity over infinity are called indeterminate forms because they do not guarantee that a limit exists, nor do they indicate what the limit is. If one does exist, when we have encountered these forms, we have had to use other methods to evaluate the limit, such as graphical analysis.
Yeah, graphical, not geographical analysis.
Table of values and algebraic manipulation. There is another very powerful method known as the L prime hospital.
So it's not L prime, it's L apostrophe. In the handout it says l'hôpital. Let's say that together, l'hôpital.
L'hôpital.
Say it like French people would say it, l'hôpital.
L'hôpital.
Okay, and that is the way it used to be spelled. Now it is spelled la hospital. La hospital, but it's still pronounced l'hôpital. So please, if you could add a little S in there and a little S in here, I'll fix this for the AD handout. But it is l'hôpital, even though you spell it la hospital. Okay. All right. So l'hôpital's rule is something that we are going to use when we are evaluating indeterminate forms. Okay, Ile, can I get you to read l'hôpital's rule?
If f of x and g of x are differentiable functions on
Okay, let's pause right there. Differentiable means one thing.
The derivative exists.
Derivative exists. Okay, Ile, keep it going.
functions on an open interval a, b containing c, except possibly at c itself. If limit of fx over g of x approaches c results in the indeterminate form 0 over 0 or positive or infinity over infinity, the limit of fx over g of x approaches c equals the limit of f prime of x over g prime of x approaches c, provided that the second limit exists or is infinite.
Oh my God, was someone chasing you? that was like a race to the end.
She said,
Here's the thing with L'Hopital's rule. The functions have to be differentiable. Derivative has to exist. And in an interval a, b containing c. The importance of c is the number that you're approaching in this limit. If when you take the limit as x approaches c of a function divided by a function, if you get the indeterminate form, then here's what L'Hopital's rule says. L'Hopital's rule says, oh, you want to take the limit as x approaches c of f of x over g of x, but you're getting an indeterminate form. You can get the same answer you can get the correct answer by taking the limit as x approaches c of the ratio of the derivatives. Let me say that one more time. You're starting off with a quotient of two functions. You're getting the indeterminate form, 0 over 0 or infinity over infinity. The way that we're actually going to find the answer, we're going to take the limit as x approaches c of the derivatives, the ratio of the derivatives. This is not, I want to make a really clear note here, not the quotient rule. Do not get this information confused with quotient rule. So let's try this first one. We already know, in fact, all four of these problems we've already done. These are the same four from the front. I want to show you a new way. David, you were like the master on this one. You said we were going to like factor and cancel. I want to try L'Hopital's rule. First of all, plug in the 2 here. We're getting 0 over 0, right? Can I use L'Hopital's rule?
Yes.
Okay, the check is, number 1, am I getting an indeterminate form? Check. Number 2, does the derivative of the top exist? Does the derivative of the bottom exist?
C.
Now that's not asking, do you know how to find them, but can you find the derivative and evaluate it too without running into like a cusp point or an infinity or does not exist? And the answer is, yeah, we're good. Same thing in the denominator. So we're going to say by LAHOP, or LOSP now, I guess. Limit as x approaches 2. Here's what L'Hopital says. Take the derivative of the numerator. You guys know what that is. 2x minus 2. Take the derivative of the denominator. What's that?
Oh, 2x minus 1.
2x minus 1. These are the derivatives. I didn't use quotient rule. Take the limit as x approaches 2. So we get 4 minus 2 over 4 minus 1, 2/3. Exact same answer from before. Exact same answer from before. No factoring, no canceling, no crazy algebra stuff. It's L'Hopital. All right, let's try the second one. Check out the second one, see if that works.
Oh, this is 1. What the fuck is you think for? It's a 1.
You have to convince me that this is a L'Hopital's rule worthy question. Plug in that 0. Square root of 4 minus 2 over 0. We do get 0 over 0. Can I find the derivative of the square root of x plus 4 minus 2 at 0? I think so. Can I find the derivative of x at 0?
Yes.
Yeah. But here's the thing, you have to put a little indication here. By L'Hope or by Lahas, limit as x approaches 0. I need to see that annoying little brother. Derivative of square root of x plus 4. 1 over 2 square roots of x plus 4. Minus 0, derivative in the denominator? 1. Take the limit as x approaches 0. As x approaches 0, 0 plus 4, I get 4. Square root of 4 is 2 times 2. We're getting 1/4. Same answer from before.
Yes.
Keep going. L'Hopital's rule tends to be every calculus student's best friend. Not because you're a bunch of losers, but just it's a really powerful tool.
See the line?
0 over 0 by L'Hopital. Limit as x approaches pi over 3, derivative of cosine of x, negative sine of x, minus derivative cosine pi over 3. Cosine pi over 3 is a constant, so who cares what it actually is? I'm taking the derivative, I get 0. In the denominator, 1. Plug in pi over 3, you get negative sine of pi over 3, which is negative square root of 3 over 2. And guess what? That matches 2. Life is good. All the friends are okay? All right, let's push a little bit more then. Okay, the last one, it was limit as x approaches infinity. Was it e to the 2x
Plus x
plus x
over x to the 4 minus 2.
minus 3x squared? All right, go for it. Mhm. We're going to get infinity over infinity in the beginning, which is bad. So, use L'Hopital. Limit as x approaches infinity. Take a derivative here. Derivative e to the 2x. E to the 2x times 2 plus 1 in the denominator. 4x cubed minus 6x. Is everybody okay with the derivatives here? What happens when you take the limit as x approaches infinity?
Still approaches infinity.
The numerator goes to infinity. The denominator? Also infinity. Guess what?
Do it again.
Not the final answer. Can't be the final answer
Oh, wait,
because
keep
this is
doing it?
indeterminate form. Can you, so here's my question. There's already a lot of you kind of snapping to like, oh, I'm just gonna do it again. Can you?
Yes.
Does this problem qualify for L'Hopital's rule?
Yes.
Number one, are we getting an indeterminate form?
R,
J's. Number two, can I take the derivative up here?
C.
And the derivative down here? Good, do it again. Oh my God, growling at me. By L'Hopital, limit as x approaches infinity, derivative of e to the 2x times 2, be careful, e to the 2x times 2, this first 2 is coming from chain rule, times 2, that's coming from this guy here. Derivative of 1 is 0, 12x squared minus 6.
Can you?
Bro,
Still
oh my God.
indeterminate. Good news, you get to use L'Hopital again. Okay, but here's the thing. Is this getting any better by these repetitions of L'Hopital?
No,
We're not seeing it get any better?
no.
It will
No
be
one's seeing it get any better?
Well, yes,
I
because
mean, yes,
eventually.
Steven, you're seeing things get better?
Yes.
Where?
Because, well, in the denominator,
In the denominator, life is getting better. Why?
because eventually it's going to be a single.
Eventually, when I take enough derivatives, I will no longer have a power of x in the denominator. One more?
No, that's no,
Two more.
Two more.
Two more.
I think we've got 2 more reps coming up. So by L'Hopital again, limit.
I was saying you eventually have one.
Oh, eventually, yes. Limit as x approaches infinity, e to the 2x times 2 times 2 times 2 again, over 24x, no surprise, infinity over infinity. One last time. By L'Hopital, you've got it, you at least have to write it. Limit as x approaches infinity, e to the 2x times 2 times 2 times 2, yes, these are all multiplication dots, over 24, take the limit as x approaches infinity. Infinity upstairs, over 24. Infinity over 24, infinity. Take another derivative.
No.
David, why not? Why are we not going to take another derivative?
It's not indeterminate.
It's no longer an indeterminate form. All of these guys here were indeterminate forms, but as soon as you stop getting an indeterminate form, you stop using L'Hopital's rule. Infinity is an answer. All the friends are okay? Celeste.
You have to write by L'Hopital's rule every time.
By Loeb or I
read
guess
Loeb.
Lahas. There needs to be some indication of what you're doing and why. On the free response part of the exam, from what I've seen, as long as you write by Loeb, you're good. Okay? All right, tonight's homework is to do 12 multiple choice questions. I'm going to give you 5 minutes.
Can I not write all this?
Yes, you can avoid the apostrophe. If the apostrophe is too hard.
No.
You have 5 minutes. Your goal in the next 5 minutes is to get the first 5 problems done.
Okay.
This is going to go really well.
This is not where we're at.
Yeah, we're not done.
This is where we're at.
No, we said homework.
Yeah.
Never mind.
Yes, Steven. What's the link? I have my piece. Yeah. The perfect one. From secure.
Aw.
L'Hopital is your friend.
the same.
They're not the same.
No, exponent.
No,
I was thinking about the degree. Each time I do degree, I was thinking about the degree, not the
Oh,
you have a little degree.
Mm-hmm.
oh, you said like the highest
Yeah,
degree, take
yeah,
the derivative
because I
of
thought
those.
it really matched me.
You're right. Is that what she's asking? She said look at the highest degree, you're taking the derivatives of those.
Yeah.
Because it's the highest degree, that's all I'm saying.
There's also something else you can do if you're gonna focus on highest degrees.
But,
Oh, we could just look at the,
the,
I bet you guys, I thought you guys would just know this answer.
Oh, we could do 1/4 the coefficients.
Right, because,
yeah, go
is
ahead.
it,
right, L'Hopital's rule is not replacing everything that you've known before, it's adding on to what you already
The
know.
harder stuff is
It definitely should be making the harder stuff easier. How can we see that?
Hey, you're cool, man.
Okay,
Wait, which one do you?
don't worry about it.
no, it's the other thing.
Okay.
Option number one. Try those totally. Option
So,
two,
when we plug in A,
x
A
cubed.
squared minus
X cubed is
zero
High
over.
value. What
We take the
happens
derivative
when it takes
of
as x approaches infinity? Something x cubed in the
A
numerator.
It's 2A,
is a constant. So the derivative of a constant is, right,
Oh, wait.
so the derivative
It
of
is
x squared,
Because we just approach.
Right, it's the constant. It would just be a
the
zero,
derivative
zero.
of x squared,
The top is the. Because A is a constant.
okay. So getting,
Right?
actually, no.
Wouldn't A be zero? Like, wouldn't it cancel out the zero?
Well, yeah, you're right. Yeah, we can-
Make sure you have an indeterminate form. Make sure the functions are
Since the bottom
differential.
is bigger.
Usually they're gonna be differential,
Yeah.
but you gotta make sure you have an indeterminate form. If you don't have an indeterminate form,
We're gonna use the other one.
I see.
don't do it.
You said.
I'm just saying, in case this comes up.
Wait, come on.
Y'all got different answers. I'm trying to figure out. If A is not a constant.
No, wait,
You said first you got B. Is it a constant, Mr. Burrow?
Is A a concept?
No, she's not a. I'm just kidding.
She's a math.
She's not a season.
A is a constant, yes.
Okay, then you can't take it out. Yeah, it's B. So you take out A when you do the first two.
I don't know, I did it twice.
I did it twice.
All right, if I can get all the friends to jump down to 4 and 5. 4 and 5.
No, it's not.
Got one more minute to do 4 and 5.
Isn't that A?
Wait, at least the. No, it's not. I feel like this is a trick. Wait, it's plus. Oh, it's not it. Oh, it's not it. You're right.
What is that for?
Yeah, what do you get for five?
I don't know. I'm
I got. Nope, it's not. It's not. What is the number?
Oh, snap.
It's zero.
Why do I still not know how to make that work? All right, so if all goes well for number 1, everybody has C. L'Hopital's rule in this case would actually have been a bigger pain in the butt. If you just saw the degrees, you knew exactly what to do. L'Hopital's rule doesn't throw out all the information. It's just another way to get to some of these things. Number 2, everybody came up with,
B.
wait, what?
C.
No, it's B.
B.
Because
It
A
is
a
for
constant.
sure B,
A is a constant, so you take it out the first time you do the
right? If you use L'Hopital's rule, you're
Yeah.
gonna get 2x over 4x cubed,
Yes.
and then you take the limit as x approaches a, and that's gonna simplify to 1 over 2a squared.
No, it's 2 over 12x
And then,
It's 2 over 12x?
squared.
and then you,
Oh, you did L'Hopital's rule twice.
You didn't have to do it twice. A is a constant, so you take it off the first time.
Oh, I know what you did. I know what you did. You, shame. The derivative of x squared minus a squared is 2x minus 0.
Yes.
In the denominator, 4x cubed. Take the limit as x approaches a, and what you're going to get is 2a over 4a cubed,
Yeah.
not an indeterminate form.
Oh, we thought it was.
So you don't get to take another derivative. You only get to use L'Hopital's rule if you have 0 over 0 or infinity over infinity. This is neither of those. Don't use L'Hopital.
Alright.
Thank you for that. All right, number 4. Everybody's good? Skip 3 because I don't think everybody gets to number 3. Number 4 is A, for sure.
Yes.
Number 5.
C.
It's not A again?
It's not.
No.
Why not?
Because x plus 5, when you plug in x approaches 5, you don't have an indeterminate form because the denominator equals 10, not 0.
Right, and 4, when you take the limit as x approaches 5, you're going to get 0 over 0, which is an indeterminate form. You get to use L'Hopital. In number 5, when you plug in 5, you get 0 over 10, not an indeterminate form, so I can't use L'Hopital's rule. This was kind of like the thing Stephen did in the last one. Is everybody mostly okay with L'Hopital? If this was a Calculus AB class, this would be the end. This would be the end of L'Hopital. This is a Calculus BC class. So this is where we get to go deeper. Right now, you guys know 2 indeterminate forms. Those 2 indeterminate forms?
0, 0,
0, 0.
Infinity over infinity.
There are 5 more.
5 more?
5
So there's 7
more.
total.
Another way to say that is if I already have 2 and there's 5 more, there's 7 total. Yes. Oh, kids these days, so smart. All right, here's another indeterminate form. Infinity minus infinity. This is an indeterminate form. Why? Somebody tell me why it's an indeterminate form. What are the conflicting rules that you might have in your head? You can't subtract infinity, okay. But what other rules might there be?
A number subtracted by the same number.
When I take a number and I subtract it from itself, I get 0. That's a rule that I might want to apply. How about the person that says infinity minus a number is
Infinity.
infinity? How about a person that says a number minus infinity?
Negative.
Negative, right? Do you guys see the conflict? This is why it's an indeterminate form. Here's another one. 0 times infinity. Why is that one an
Because
indeterminate
anything
form?
times.
I see Lewis. I'm hearing from Aaron. I'd love to hear from some new friends. Some folks have been really quiet, except for Speed Racer here. Myra,
If you multiply number times 0, it equals 0.
a number times 0 is 0. That's a rule.
But a number times infinity.
But a number times infinity is infinity conflict, indeterminate form. Here's another one. Another one is 0 to the power of infinity. Right, 0 to any power is 0. But take a number and raise it to the infinity power, I would expect it's either going to get really big or really small. Other ones, 1 to the infinity. Infinity to the power of 0. These are definitely tricky ones, and I always forget. God, why do I always forget it? That other one. Not only did I forget it, I forgot my handout. Why, God, why?
Wait, so that you saying that you do 5 more ones?
Wait,
They have 5 more things.
1 to the power of infinity.
What? Oh, wait.
So there's 8 in total.
Okay, hold on. Let's find out if there are 8 in total or 7 in total. I'm so excited. Let's find out. 1, 2, 3, 4. Okay, we got infinity minus infinity. Infinity times 0. Infinity to the 0. 0 to the infinity. Ah! Dang it.
So there's 8 in total.
There's 8 in total.
0 to the power of
Why
0?
would someone ever write that down?
You will. All right.
Don't be that guy.
You don't know anything
That's
about
1.
0. Okay, 0 to the 0. I heard somebody just tell me that the answer has to be 1.
No, it doesn't.
Because anything to the power of 0 is 1, but the other rule that you're thinking of?
0 to any power.
0 to any power is 0. This is why these are indeterminate forms. Everybody okay? There are a total of 8, not 7. My bad. Apologies. We'll edit the tape. Now, here's the thing. None of these are A-B questions. These are all B-C questions. And the trickiest ones are these guys over here. All of these are going to require logarithmic differentiation. Oh my God, I'm so excited. Don't be absent tomorrow. All right. Okay. First one, let's try some cleverness here. Is this an indeterminate form? Have a conversation with somebody near you. If it's an indeterminate form, tell me why.
It is.
Why? Have a conversation. Why is this an indeterminate form?
It is.
Because 0 times.
Zero times any.
Oh, we're talking about the problem.
I keep hearing that this guy over here is 0 times infinity. Why? Where's the 0 coming from? Lewis sees it.
Oh!
Where I keep hearing you guys are telling me 0 times infinity here. Lewis can tell me why this is 0 times infinity. Celeste can tell me why it's 0 times infinity. Polymon, why is it 0 times infinity? As x approaches infinity, what happens here? The graph of e to the negative x decreases from left to right. 0 times infinity. Okay, so this is 0 times infinity. L'Hopital's rule is not designed for 0 times infinity. L'Hopital's rule is wonderful for infinity over infinity and 0 over 0. It works well with fractions.
Turn it into a fraction.
Can you legally turn this into a fraction?
Yes.
Yes.
Square root of x over e to the x.
Okay, we're just doing some legal stuff here, right? Instead of e to the negative x, I'm going to send it into the denominator as e to the x. Is that legal?
Yes.
Is that better? Well, at first glance, you might say, well, no, that's not better because it's infinity over infinity. But oh my God, this is so much better because now I get to use L'Hopital. So use some L'Hopital. Right? So you're going to take limit as x approaches infinity. And Celeste, I heard what you said. I'm going to come back to you in just a second. 1 over 2 square roots of x over e to the x. Right? Derivative square root of x is 1 over 2 square roots of x. Derivative of e to the x is e to the x. Now, you might say, wait a second though, this is now 0 over infinity. Let's do a little bit of algebra here. 1 over 2 square roots of x divided by e to the x is the same as limit as x approaches infinity, 1 over 2 square roots of x, e to the x. If you're not sure what I just did, keep it, change it, flip it.
Dividing, so you bring it down.
Right, this fraction divided by that one means take the reciprocal of the denominator and multiply. Take the limit as x approaches infinity. 2 times, this guy gets close to infinity. E to the x gets close to infinity. So we're getting 1 over infinity. And 1 over infinity? Top is getting close to 1. The denominator gets bigger and bigger and bigger and bigger, so the whole fraction is 0. Now, Celeste, I heard you really early in this problem say infinity? No, 0?
Yeah, because
Why? How did you decide?
Well, because when you write square root of x over e to the x, you said that e dx always goes faster than any other function, so it has to equal.
Okay, so you're comparing square root of x with e to the x. Exponentials grow faster, so the answer had to be 0.
and e to the x doesn't change because the derivative of e to x is e to the x.
The derivative is e to the x, e to the x. We'll get all the stuff going on. Is everybody okay? Other than just that. All right, good. All right, show me what you can do with number 3. Stephen, if I'm writing over here, can everybody still see?
Yes.
Thanks. And for all the AV teachers watching, this is not what we're worried about for the calculus AV kiddos, just for the BC friends. Hopefully everybody's getting infinity over infinity right out of the gate. Alright, if I could jump into the conversation just for a second. We get infinity over infinity, clearly L'Hopital. Take a derivative, derivative of the numerator is 1, derivative in the denominator, chain rule. 1 over 2 square roots of x squared plus 1 times 2x. I did a little canceling over here. 1 divided by a fraction, keep it, change it, flip it. Square root of x squared plus 1 over x, take the limit as x approaches infinity, infinity over infinity. Is everybody okay with this first move? Okay. L'Hopital again. Limit x approaches infinity. The derivative in the numerator, 1 over 2 square roots of x squared plus 1 times 2x over 1. If I simplify that, I get the limit as x approaches infinity, x over square root of x squared plus 1, which is infinity over infinity, which means I should go and do L'Hopital again. Anybody notice anything?
Cycle.
What was that?
Gonna repeat itself. Wait.
This guy here is exactly where we started. We're 2 derivatives in and we got the same function back. So what's going to happen with L'Hopital? You're going to take the derivative again. You know where you're going to get to? You're going to get over here, which is infinity over infinity. You're going to take the derivative again. Guess what's going to happen? It's just going to keep cycling. You're in this infinite loop. You are stuck. And sometimes my T's look like F's. That's a T. That's a T. For all the good girls in the room who have no idea what I'm talking about, good for you. All right, tonight's homework is multiple choice questions involving L'Hopital's rule. Tomorrow, we continue at L'Hopital, day 2. Where do you stop?